guys, here we are on Friday. We made it to the end of the first week. Way to be. All right. So yesterday we talked about slopes that are parallel and slopes that are perpendicular. If you remember, slopes that are parallel are equal. Okay. And remember, the slope is always the number in front of the x. Okay. Now, perpendicular, they are flipped over. It's the number in front of the x when there's no other x's. That's the thing I should tell you. Okay, so perpendicular, they are flipped over. So if like there's a fraction, it's a over b, they are flipped over, and then you flip the sign. So if it was positive, make it negative. If it was negative, make it positive. So right here on number 1, my slope is actually hidden. It's the number 1. Okay, so my slope here is 1. Now you need to remember this is over 1 for the second part. So parallel, my slope is just 1. The slope is going to be flipped over in the opposite sign. So it's going to be still a 1 over 1, but notice it's the other 1 on top. And now instead of positive, it's negative. So if I reduce this just becomes negative 1. Okay, on number 2, if you notice the number in front of the x, and there are no other x's, the number in front of the x is a negative 3. So my parallel would be negative 3. Now you need to remember this is actually negative 3 over 1. So if this is negative 3 over 1, to flip it over, I would put a positive 1 over a 3. And then I need to flip the sign. So it was negative. Now I'm going to make it positive. So then that means that this is a positive 1/3. Okay, on this last one that has an equation that's not just points, it has a 2/7. Okay, so for me, that 2/7 is exactly what I put for parallel. Notice that there's only one x. In each of those problems, there's only one x. And so it's the number in front of the x that will be your slope. So we've got 2/7. Now, if I want to flip this over, this becomes 7/2. And if it was positive, now it's negative. Okay. Now on number 4, I like to make tables. So on number 4, I'm going to make a table up here. And I'm going to put 4 by it so we know it's problem number 4. Okay, so I'm going to make a table. Here's my x's, here's my y's. So I'm going to do 3, 0, and 3, 200. So my change in my x is nothing. But my change in my y went up 200. Now, if you remember, the way we do this is we do the change in y over the change in x. So my slope is technically 200 divided by 0, but anytime I divide by 0, this is known as undefined or undef. That's how I tend to write it. Now, if I want to do perpendicular, I'm going to flip it upside down. So now it's 0 over 200, and I flip the sign. Well, now, if I type this into my calculator, instead of giving me error, it will actually tell me 0. So it's undefined, and 0 will be perpendicular. So parallel will be undefined, perpendicular will be 0. Okay, on number 5, I'm going to go ahead and make the table down here. Here's my x's, here's my y's. So negative 2, 3, and 7, 24. If you notice on my x's, we go up 9, and on my y's, I went up 21. So that means that my slope, now we always do y over x, so 21 over 9. If I reduce this fraction, it becomes 7/3, because 21 divided by 3 is 7, and 9 divided by 3 is 3. So that means parallel would be 7/3. Now, if I want perpendicular, I need to flip this over. So it's 3/7, and it was positive, so now it's negative. Again, if you have questions on things like this, you need to be leaving comments. You need to be answering the questions, asking questions, leaving a comment. It's all graded, so you might as well do it for the credit, and then it might actually help you in the long run. All right, let's take a look here. Okay, it says determine whether the line through the pairs of points are parallel, perpendicular, or neither. So let's see. So the first thing I always do is I make a table, put my x values there, I put my y values there. So my x values are like 5, -4. So there's my first point. And my second point is 10, 0. So now let's look at this. We've got 5 to 10 and -4 to 0. This went up 4, my y's did, and my x's went up 5. So my slope is 4/5. Okay? And then on the second line, let's go ahead and make a table. We've got x's and y's. We've got 5, -3, 10, 1. My x's went up by 5s. My y's went up by 4. And then my slope is again going to be 4/5. So right now it has the potential of possibly being parallel. Now, either it's parallel or all points are the same. So let's take a look. So this one's at 5 at the same time. Are they at the same y value? No, they're not. So these are actually parallel. Isn't that pretty? I like that. Okay. If you have questions, please leave them in the comments. Okay, right here, we're going to look at two equations that are perpendicular. So the first thing we need to do is make them so they all say y equals. So I'm going to subtract 2x from both sides. So I have -3y equals -2x minus 12. Then I divide everything by -3. And I get y equals 2/3 x plus 4. And the part that I super care about is this 2/3. Okay, and keep that in mind. All right, so then on B, we've got y equals 3x plus 7. That's already pretty. So our slope here is 3. So far, nothing perpendicular. All right. So right here, we don't have anything done yet. So let's subtract 3x from both sides. We have y equals -3x plus 8. Okay, so my slope is 3. Now, is -3 perpendicular to 3? Well, why not? Well, if you look, if I took 3 and I flipped it over, this would be 1/3. Okay? And then if I flip the sign, then it would be -1/3. So these two are not perpendicular. Okay? All right, let's take a look at D. Let's see if this one is going to be perpendicular to anything else. So let's subtract 6x from both sides. Okay, so I have 4y equals -6x plus 1. Now I'm going to divide everything by 4. And I get y equals, now -6/4 becomes -3/2 x, and then this would just be plus 1/4. Nothing super exciting there at the end. Okay, now this is my last slope. Is this one anything flipped over and flipped the sign? Do you see it? You're right. It's A and D. So I would write A and D are perpendicular. Remember, that's the symbol for perpendicular. Because BECAUSE, they are opposite reciprocals. In other words, 2/3 flipped over would be 3/2 and negative. Okay, if you have questions, again, leave them in the comments. Okay, we're going to do the same thing here. We're going to determine if these are parallel, perpendicular, or neither. So the first thing I'm going to do is I'm going to make a table. Got 2, 6. Got 1, 3. This went down by 1. This went down by 3. Now remember, I always put y over x, so this would be -3 over -1, which is just 3. So my slope is 3. Okay, so let's take a look at this one. Here's my x, here's my y. So I've got 0, 10, and 4, 22. This went up by 4. This went up by 12. So now if I do 12 divided by 4, I get 3. So 12 divided by 4 is 3. That means my slope is, in fact, 3. Now, this is where we have to be careful because they could be parallel or they could be the same line. So now we have to check. So the first thing that I'm going to do is I'm going to write the equation for this line. I'm going to pick the one with the 0 in it. So this is going to be y minus my y value equals my slope times my x minus my x value. So I have y minus 10 equals 3x. So if we add 10 to both sides, we get y equals 3x plus 10. Now we're going to do the same thing over here. And I'm going to pick the numbers 1, 3 because 1's pretty small and I like 3. So I feel good about that. Okay, so I've got y minus 3 equals 3 times x minus 1. So let's distribute the 3. I have y minus 3 equals 3x minus 3. So if I add 3 to both sides, y equals 3x. These equations are not the same, so these are parallel. Beautiful. All right, we're going to do it again. Try this one before I walk you through it. Okay, so pause the video here and give it a try. All right, so we've got 1, 7 and 10, 70. So here's my x, here's my y. 1, 7, 10, 70. So this went up by 9, and this went up by 63. And if we take our y, we divide by our x, 63 divided by 9 is 7. Okay, so let's do the same thing over here. Here's my x, here's my y. This is -4 and -9, 3 and -10. -4 to 3 is going up 7. -9 to -10 is going down 1. So now if I divide these, I get -1, because I always do y divided by x. So -1/7. Now, are these parallel? No, because they're not the same. Are they perpendicular? Yeah, because -1/7 is just 7 flipped over. And then the sign switch. So these are perpendicular. All right, let's take a look here. Now we need to write an equation for a line that passes through 6, -2 and is parallel to 1/2. Well, if I know 1/2 and I know the point already, I can graph my line really easily. I go up 1 over 2, up 1 over 2, and I can go the other way. So I go down 1 over 2, down 1 over 2, down 1 over 2. Do you see how these lines will never intersect? It's because they have the same slope. It's because they are parallel. Okay, so these are parallel. So now if you look, see where it intersects my y-axis? That makes it so you can easily write the line. So I've got y equals, and I already know it's 1/2 x. Now my y-intercept is -1, -2, -3, -4, -5. So there's my equation for that line. If you need to, go watch that again so you can see it. Okay, here's the next one. So a line passes through the point 3, 2. So I need to go over 1, 2, 3, up 2. It needs to pass through that point. And it's going to be perpendicular to the line 3x minus 1. So I'm going to graph that line. I'm at -1, and then I've got 3x. So I go up 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3 over 1. And then I can go the other way. So down 1, 2, 3, left 1, down 1, 2, 3, left 1. You can also use Desmos to graph this for you if you don't want to graph it yourself. Okay, so there's my line. Obviously, I draw it perfectly straight. No, I don't. Okay, and we want to make a line through this point that's perpendicular to. So I'm going to take my slope of 3, and I'm going to flip it over. So I need to remember that it's over 1. So I'm going to flip this number over, and I get 1/3, and I need to flip the sign. So it's -1/3. Okay, so that means down 1, right 3. So I'm here. I want to go down 1, right 3. Down 1, right 3. Or I can go the other way, up 1, left 3. Up 1, left 3. Okay, so here's my pretty graph. And if you look, these look pretty dang perpendicular. Okay, the cool thing about doing it this way is then you can see where it crosses. So I know it crosses at the point, my y-intercept. So my equation so far is y equals, and then I have my -1/3 x. And then it crosses at 1, 2, 3. Up 3. there's my equation for that line. Again, if you got lost, please go rewatch it a couple of times. See if you can do it on your own first. Okay, this time we're not given a picture. So the line passes through the point 3, 2 and is parallel. Does parallel mean we have the same or opposite reciprocals? You're right, it does mean we have the same. So we have y equals negative 3x minus 2, so my slope is negative 3. So my equation right now, I'm going to have y minus y1. So I'm going to have y minus, here's y1, 2. Because this is x, this is y. Equals, and then my slope is negative 3. Then in parentheses, I'm going to put x minus, and then I'm going to take my x value. So I'll circle my x value in a different color so we know what I'm doing. And then I'll circle my 2 in blue and then right over it in blue. Okay, so that's where those numbers came from. All right. So now I'm going to take this and distribute. Technically, you could be done. You can also simplify from here. So we'd have y minus 2 equals negative 3x plus 9. Then you could add 2 to both sides. And you get y equals negative 3x plus 11. And that's my answer. All right, we're going to do one more, and then the notes are done for today. All right, you got that? You so got this. I believe in you. Okay, so here's my point. This is my x. This is my y. So my x is a 4. My y is a negative 2. Okay. Then I've got y. Now I just need to figure out my slope. So perpendicular. So if the slope here is negative 2, how do I do opposite reciprocal? You're right. I flip it over. So I flip it over. And I change the sign. So it was negative. So now it's positive. So my equation right now is y minus negative 2 equals, and then I have a 1/2, and we've got x minus 4. I'm going to put a 1/2 over there. Okay, so now if you want, you can simplify. So y minus negative 2 is the same thing as y plus 2. And then we've got a 1/2 x, because I'm distributing my 1/2. And then 1/2 times negative 4, if you don't know, you can use a calculator. I happen to know this one, so I'm just going to put minus 2. Okay, so now I'm going to subtract 2 from both sides. Again, if you don't know what negative 2 minus 2 is, use a calculator. There is no shame in that. So we've got y equals 1/2 x, and then negative 2 minus 2 is a negative 4. And there's my equation. All right, so this is what we did. We identified, we can write the equation of a line that is parallel to another that goes through a specific point, and we learned how to write the equation of a line that is perpendicular to another line that goes through a specific point. If there is any more help that you need from this, please check in on my office hours today, or go ahead and leave a comment asking all the questions that you need, and maybe someone will answer them, like me. Okay, love you all. I'll see you soon. Bye.